Hello everyone. In our last demo, we demonstrated how the electrical conductivity of silicon can be changed by over 6 orders of magnitude by adding dopants that can increase the number of free or mobile charges in the material. Today, we'll show how we can use light to break electronic bonds in silicon and create free mobile charges. The principles we'll be using today can be applied to everything from sunscreen to, of course, solar cells. We'll use the undoped or intrinsic silicon sample from our last demo and measure how the conductivity changes when we shine light on it.
Our setup is identical to that of last time. We'll take a piece of silicon with metal contacts. We'll use an ohm meter that we connect to our sample via metal wires to measure its conductivity. The measured resistance will be determined by the conductivity and the size and shape of our sample. Finally, we represent the conductivity in terms of our measured values and relate it to the number of free mobile charges and the material properties of silicon. We'll first measure the conductivity of our sample in the dark, and then shine light on our sample and see how the conductivity changes.
Our ohm meter is hooked up to our sample, and we measure a resistance of around 120,000 ohms, which is equivalent to a conductivity of around 2 10,000ths inverse ohm centimeters. Now let's flip on the light. We can see that we measure a slightly lower resistance of around 40,000 ohms. But what is light doing to affect the conductivity so much? Let's zoom into the atomic level and explore why.